Hello everyone, my name is Ajay Medvi from Aeronautical Engineering. In this presentation, I am going to discuss about concept area of flight mechanics, that is aircraft operation safety, aviation safety. Aviation safety means the state of an aviation system or organization in which risks associated with aviation activities related to or in direct support of the operation of aircraft are reduced and controlled to an acceptable level. It encompasses theory, practice, investigation, and categorization of a flight failure, the prevention of such failure through regulations, education, and training. Aviation safety hazards: foreign object debris, misleading information and lack of information, lightning, ice and snow, wind shear, or microburst. Foreign object debris (FOD) includes items left in the aircraft structure during manufacture, repairs, debris on the runway, and solid encountered in flight. Example: hail and dust. Such items can damage engines and other parts of the aircraft. In 2000, Air France Flight 4590 crashed after hitting a part that had fallen from a departing Continental Airlines DC-10. Misleading information and lack of information. A pilot misinformed by a printed document, manual, or map, etc., reacting to a faculty instrument or indicator in the cockpit or on the ground, or following inaccurate instructions or information from flight or ground control, can lose situation awareness or make errors, and accidents or near misses may result. The crash of Air New Zealand Flight 901 was a result of receiving and interpreting incorrect coordinates, which caused the pilots to inadvertently fly into a mountain. Lightning. Boeing studies showed that airlines are struck by lightning twice per year on average. Aircraft withstand typical lightning strikes without damage. Ice and snow. Ice and snow can be major factors in airline accidents. In 2005, Southwest Airlines Flight 1248 slid off the end of a runway after landing in heavy snow conditions, killing one child on the ground. Even a small amount of icing or coarse frost can greatly impair the ability of a wing to develop adequate lift, which is why regulations prohibit ice, snow, or even frost on the wings or tail prior to takeoff. Air Florida Flight 90 crashed on takeoff in 1982 as a result of ice snow on its wing. Engine failure. An engine may fail due to function because of fuel starvation and mechanical failure due to metal fatigue. Mechanical failure due to improper maintenance. Mechanical failure caused by an original manufacturing defect in the engine and pilot error. Wind shear or microburst. A wind shear is a change in wind speed and or direction over a relative short distance in the atmosphere. A microburst is a localized column of sinking air that drops down in a thunderstorm. Both of these accidents are potential weather threats that may cause an aviation accident. Strong outflow from thunderstorms causes rapid change in three-dimensional wind velocity just above ground level. Initially, this outflow causes a headwind that increases airspeed, which normally causes a pilot to reduce engine power if they are unaware of the wind shear. As a result, as the aircraft passes into the region of the downdraft, the localized headwind dimensions, reducing the aircraft's airspeed and increasing its sink rate. Then, when the aircraft passes through the other side of the downdraft, the headwind becomes tailwind, reducing lift generated by the wings and leaving the aircraft in a low power, low speed descent. Stalling. Stalling an aircraft increases the angle of attack to a point at which the wings fail to produce enough lift. It's dangerous and can result in crash if the pilot fails to make timely correction. Devices to warn the pilot when the aircraft speed is decreasing close to stall speed include stall warning horns, now standard on virtual all-powered aircraft, stick shakers and voice warnings. Stall is basically occurs due to sudden reduction in the lift. Stall is a dangerous thing in an aircraft because when a stall is occurred, the airplane will able to fall down. Before happening, the pilot must know about the stall condition and he will instantaneously take the decisions by changing its angle of attack or airspeed. Human factors. Human factors include pilot error or another potential set of factors, and currently the factor mostly common found in aviation accidents. Much progress in applying human factors analysis to improving aviation safety was made around the time of World War II by such pioneers as Paul Fitts and Alphonse Chapin. However, there has been progress in safety throughout the history of aviation, such as the development of pilots checklist in 1937, pilot fatigue, piloting while intoxicated, pilot suicide and murder, human factors of third parties, controlled flight into terrain. Before going to the flight, the air hostess and other crew members will shows the safety precautions before takeoff. That really helps a lot. Even small particle can damage whole aircraft, or maybe in some cases it will crash. Ground damage. Various ground support equipment operating some proximate to the fuselage and wings to service the aircraft and occasionally cause accident damage in the form of scratches in the paint or small dents in the skin. However, because aircraft structures play such a critical role in the safe operation of a flight, all damage is inspected, measured, and possibly tested to ensure that any damage is within safe tolerance. Volcanic ash. Fumes of volcanic ash near active volcanoes can damage propellers, engines, and cockpit windows. In 1982, British Airways Flight 9 flew through an ash cloud and temporarily lost power from all four engines. Runway safety. Types of runway safety includes runway extrusion, an incident involving only a single aircraft making an inopportune exit from the runway. Runway overrun, a specific type of extrusion where the aircraft does not stop before the end of the runway. Example: Air France Flight 358. Runway incursion, incorrect presence of a vehicle, person, or another aircraft on the runway. Runway confusion, crew misidentification the runway for landing or takeoff. Safety improvement initiatives. The safety improvement initiatives are aviation safety partnerships between regulators, manufacturers, operators, professional unions, research organizations, and international aviation organizations to further enhance safety. Some major safety initiatives worldwide are Commercial Aviation Safety Team in the US. The Commercial Aviation Safety Team was founded in 1998 with a goal to reduce the commercial aviation fatality rate in the United States by 80% by 2007. European Strategic Safety Initiatives. The initiative objective is to further enhance safety for citizens in Europe and worldwide through safety analysis, implementation of cost effective action plans, and coordination with other safety initiatives worldwide. After the disappearance of Malaysia Airlines Flight 370 in June 2014, the International Air Transport Association said it was working on implementing new measures to track aircraft in flight in real time. A special panel was considering a range of options, include the production of equipment especially designed to ensure real-time tracking, since pilot error accounts for between one-third and 60% of aviation accidents. Advances in automation and technology could replace some or all of the duties of the aircraft pilots. Automation since the 1980s has already eliminated the need for flight engineers in complex situations with severely degraded systems. The problem solving and judgment capability of humans is challenging. Sorry. Humans is challenging to achieve with automated systems. Regulations. These are the some authorities across the globe. Directorate General of Civil Aviation India. Now we are calling DCGI. Civil Aviation Authority UK. Department of Infrastructure, Transport, Regional Development and Local Government Australia. European Aviation Safety Agency. Federal Aviation Administration. Irish Aviation Authority, Transport Canada, and Directorate General of Aviation, Indonesia. Thank you.